Okay, so 8-1, Pythagorean Theorem. Alright, this is Unit 5. We are just now beginning Unit 5. Okay, Unit 5 is all about right triangles, so everything to do with right triangles. The only thing you know about right triangles right now, as of this point, is Pythagorean Theorem. This is just the first section. We will do a whole bunch of other new stuff in this unit, so don't get too excited. But most people really do like this unit. It's a little scary at first when we get into the trig stuff, but most people really, really love it by the end. Okay? Not everything in this section will be review, so we will do some new things with the Pythagorean Theorem that you haven't seen before. But most of you know the basics. Okay? If you have a right triangle, you have A, B, and C, then A squared plus B squared equals C squared. C is always the hypotenuse. Right? Always, 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 always. Okay, couple terminology. Okay, I don't know why I just put two P's. Pythagorean triple. If I ask you, is this a Pythagorean triple? All that means is that the three numbers fit into the formula. Okay. Some examples of Pythagorean theorem, some common ones is 3, 4, 5. This is actually an extremely common Pythagorean theorem. Construction workers actually use this theorem all the time to make sure that they have right angles. They'll measure off 3 and 4 and make sure that the third measure is 5 to make sure it's a 90-degree angle. If you memorize this one, it will save you a lot of time because you will see this combination often. The other one is 5, 12, and 13. You'll see that one often as well. And then there's more, but I'm just going to give you those two. But these are the two most common Pythagorean triples you'll see. So if you can memorize them, then it'll save you from having to use the formula. Also, any combinations of these, any multiples. Okay? So if 3, 4, 5 is a Pythagorean triple, then wouldn't 6, 8, and 10 also be? And if 5, 12, and 13 is, then 10, 24, and 26 would also be. So if you notice that something is a multiple of one of these, it will work as well. Okay. All right, let's get to some basic examples. All right. First example. It's going to be pretty simple. When the x is the hypotenuse, in this example, x is the hypotenuse. Okay, so how do you solve a problem when x is the hypotenuse? It's pretty easy. X is your c, right? So it's just 25 squared plus 10 squared equals x squared. Okay. Now, my regular ed guys obviously could just type this in the calculator and get that x is equal to 26.92. But my pre-AP kids, I'm going to want to teach you something here. This will become extremely important later on when you're doing calculus. Those of you that go on to pre-calculus, this will be very, very, very helpful. 25 squared is 625. 10 squared is 100. Add those together, you get 725. Oh, I'm sorry, I forgot on this one. You would have x squared equals 725. To get from here to here, don't forget you square root. Okay? So to get rid of the square, you just square root 725, and that gives you 692. Okay? Alright, over here, 725 equals x squared. So again, x is going to equal the square root of 725. But I don't want you to type this in the calculator. I want you to simplify this. Give me the simplified version. In order to do that, you need to develop a factor tree. Okay? If I divide this by 5, I get 145. And if I divide that by 5, I get 29. 29 is a prime number, so it's 5. Okay? So, here's my little story. Here's how you simplify this. Okay? When you get married, two people get married. Okay? And if you've ever been to a religious marriage ceremony, they talk about the man and the woman coming together and being one with God. Anybody ever heard that before, where you're one with God? Okay? So think about it that way. Anybody who has partners, anybody who's matched together is going to get married and be one person. So 5 can marry a 5, and they're going to come together and be one person, and they go outside of the home, they go out of the church, they go out of the house, they leave their parents' homes, and they go out in the world, right? Okay? 29 is kind of lonely. 29 doesn't have anybody to marry, do they? Okay, so they are going to stay at home with their parents, in their parents' basement, lonely and alone inside the house. Okay, and that is the simplified version of a radical. Okay, so that's like my little story on how to simplify radicals. All right, next example. Okay, in this example, the x is a leg of the triangle. Remember, a leg is any side that's not a hypotenuse. Okay, so x is a leg. 12 is still your hypotenuse, right? So that goes by itself. So we're going to have 6 squared plus x squared equals 12 squared. That's 36. X squared equals 144. Subtract 36. X squared equals 108. So to get rid of the square, you square root, and x equals the square root of 108. So if we were going to simplify this again, it would be 2 and 54, and 2 and 26, and 2 and 13. All right, so find somebody to marry. They can get married. So that brings 1, 2 outside the house. And the 2 and the 13 are pretty lonely, right? They stay in the house in their parents' basement. Okay? So you get 2 square root of 26. You can just multiply the 2 that are left inside together. Okay? Again, my regular ed kids can just type this in the calculator and get the decimal. Alright. What happens if you have that picture? We have 2 x's in the picture. Can we still solve it? You sure can. This is still your hypotenuse, right? Okay, so we have x squared and x squared equals 16 squared. The problem is right here. A lot of people want to tell me that this is x to the 4th. Okay? If I have 1 apple and I add another apple, how many apples do I have? You have 2 apples. The coefficients get added, but the variable stays the same. Remember that from Algebra 1. I know it's been a while. 16 squared is 256. Divide by 2. X squared equals 128. Take the square root. Okay. That gives you 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So we've got a 2, a 2, and a 2, and then 1 by itself. So that's, they go outside, and they go outside. So that gives us 2 times 2 times 2 on the outside. And then we have the poor lonely 2 who's at home alone in their parents' basement. So that's going to be 8 square root 2. Alright, so that's all the 3 possibilities you'll have with Pythagorean Theorem. Now let me show you something new. Something new you've never done with Pythagorean Theorem. We can actually use Pythagorean Theorem to classify triangles. Now when we say classify, we're going back to Unit 4 at the beginning when we're talking about what kind of triangle is it. Is it an acute triangle, is it obtuse, or is it right? Okay, let me show you an example. If I have 7, 8, and 9, if those are the side lengths of my triangle, let's see if it's right. First, check to see if it's right. To check to see if it's right, you use the Pythagorean Theorem. 7 squared plus 8 squared equals 9 squared. Okay, 7 squared plus 8 squared equals 113, and 9 squared equals 181. Okay, so this, I'm sorry, 81. So it is not a right triangle. What kind of triangle is it? Okay, well, you're always going to put your hypotenuse on the right side, right? So this number represents the hypotenuse. If the hypotenuse, or the so-called hypotenuse of the triangle, is smaller than these two sides squared together, then that means the angle across from it has to be smaller. So if the angle across from it is less than 90 degrees, then that's going to make it an acute. Okay, so when the hypotenuse is smaller, then the triangle is acute. So you're just looking at the hypotenuse number. Let me give you another example. 6, 14, and 11. Now this one's tricky. Which one's the hypotenuse? Is it the 11 or the 14? It's going to be the 14 because your hypotenuse is always the biggest side. No matter what, no matter how I list these numbers, your hypotenuse is always going to be the biggest side. Okay, so make sure you're putting them in correctly, but if you do, you get 157 and 196. In this case, this is my hypotenuse, and it's bigger than the other two sides. So that means the triangle is going to be obtuse. If it were to equal, then you would tell me that the triangle is right. But if it doesn't equal, then you determine if it's bigger or smaller. Smaller means acute, bigger means obtuse.